we have covered everything related to the DC motor control. So right now we can generate a PWM signal with a varying duty cycle. And the next important step in designing the balancing robot is to use incremental encoders to get the position and rotating velocity of the wheels. Without this information, our robot will keep drifting, so it will be impossible to achieve stability. But if we can uh, identify how fast our wheels are rotating, we can integrate that information to the control algorithm to eliminate the drifts. So next step, as I said, we will cover incremental encoders. But if you don't know what it is and it's your first time um, encountering encoders, don't worry, because first, of course, I will explain the basics, the fundamentals. Then we will switch to more advanced, more practical aspects of the incremental encoders. So to understand, let's consider this very simple scenario. So imagine that we have some light transmitter. So probably it will be infrared transmitter. So it's emitting light in this direction. And also we have infrared receiver. So it detects the light. And if we have nothing in front of the transmitter and receiver, if we don't put any objects, of course the receiver will not sense the presence of the infrared light, so the output of the receiver is low. But as soon as we put some object in front, what will happen is that infrared light will be reflected by this object, and the infrared light will reach the receiver. So due to that, the receiver will the receiver output will be high state, so it will detect the infrared light. Next, let's consider more advanced case. So imagine that we have an object which has many lines. So this is the black line. So light cannot go through this line, and also we have the transparent line. So they are alternating. So if we have a black line, what would happen? That we have light get reflected. If it's a transparent, the light will go through the object. So infrared receiver will not sense the light. And the interesting thing will happen if we move this object in front of the inner receiver and transmitter. So let's imagine that we're moving fast up and down. So in that case, what would happen? That in some cases the receiver will sense the presence of the light, infrared light, so we have the high state. Next time when we have this transparent line, we have low state, the high state. So what it means is that if we move this object in front of the receiver, the receiver will generate the following signal. We call it usually quadrature signal. So this high state, meaning that we have these black lines, this low state, meaning that we have this transparent line. And by just counting the number of edges, we can find out how many lines passed in front. So for example, if we have counter, and if it counts 10 edges, meaning that we have 10 lines passing in front of the receiver and transmitter. So meaning that by just counting it, we can find out how fast, or in other words, the velocity of this object. And finally, we can get the position, the relative position of this object. So this is how incremental encoders work. So it just sends the presence of the lines and outputs these quadrature signals, and just counting the number of edges of the signal, we can find out the position and the velocity of an object. And for example, this is how linear, so we call this thing strip. So so we usually have encoder strips. So this is the one of the strips I have. It's like a transparent, but it's not fully transparent. It has 180 lines per inch. So it has tiny lines. So I can put like an infrared receiver and transmitter, and when I move an up and down, it generates this quadrature signal. And for example, I have this motor I showed you before. It also has these lines, but instead of just a line, we have disk. And this disk also contains these tiny lines. Maybe you can see it. It's just over there. So we have disk here, and inside of this black thing, we have a transmitter and receiver. And here we have the output. So it's written there actually. So we have encoder lines, encoder outputs as these white and yellow lines. So these from white and the yellow wires, we can get these quadrature signals. And also you also find not only optical encoders, but sometimes you can get also magnetic encoders. So here I have this tiny motor, and this motor also has linear encoder, but instead of these optical sensors, we have magnetic sensors, and we have just this black magnet. So when it rotates, these sensors sense and also counts the pulses. So it works in a very similar way. So the output is the same, but the technology could be different. And also on the web, I found this article on Wikipedia, which is also quite nice. So if you have time, you can go through this article as well. And also I want to show this video. Go just over there. As you can see there, we also have disk, and probably these black things are all magnets. So here we have a magnetic sensor which counts the number of magnets passing through the sensor. So it works in a similar way. Another important thing is that using just one receiver, we cannot identify the direction of rotation. So whether it is moving up and down, or let's say whether the disk is rotating clockwise or counterclockwise, we get the similar signal. And to differentiate, to find out the direction of movement, or we need to use two receivers, and we usually denote them A and B. And by using two receivers, we can find out also the direction of movement. So this illustration shows the operating principle of it. Okay, so finally we know how the encoders work. We basically know that it generates a quadrature signal, and we have to count the number of edges. And to do that, of course, we can use different approaches. And to do that, of course, we can use different methods. One of the methods is just to connect one of the pins of the microcontroller, and by constantly checking it. Other way, we can use external interrupts. But the best way to count this number of edges is using encoder mode of the timers. So in STM32 microcontrollers, the great thing is that the timers already have this feature of reading the encoder signals or in other words, the quadrature signals. So it has two inputs. So we just need to connect the output of the encoder to the microcontroller. Then when it starts generating these pulses, we have just a counter which just counts the number of pulses happened, and also it considers the direction of movement. So if we have one direction, it increments, and if it changes the direction, it decrements. So it considers all these possible scenarios. So what it means is that this problem of working with encoders narrows down to configuring the timer and just reading the counter of this timer, and that's it. So I really like this feature of the timers, and in most of my projects I use this timer encoder mode of STM32 microcontrollers. So this article is again on my website, and you can find the link to this article on my in the description below, and also you can go through this article. And next thing, we will configure the timer in encoder mode, and we will get the rotary position and velocity of the motor. And of course, if you have any questions or comments, please drop them in the discussion section or on the community page. So see you in the next lesson.